If you work anywhere near manufacturing or power generation, you already know water is everything. But what you might not realize is that every single drop, the water you take in and the water you send back out, is governed by a pretty complex set of federal rules. So today, we're going to break down a key piece of that rulebook, 40 CFR Part 125. Think of it as the official playbook for protecting our nation's waters.
Okay, so here's our game plan. We'll start with the basics, what this regulation actually is. Then we'll look at its two main sides, the rules for water going out of a facility and the rules for water being pulled in. After that, we'll see how it all works in the real world, and finally, get into why this is so incredibly important for both the environment and for business.
All right, first things first. To really get a handle on Part 125, you have to know where it fits in the grand scheme of things. See, it's not just some standalone rule. It's a supercritical gear in a much, much larger machine that was created by the Clean Water Act. And that whole system is built around this one permit program, the NPDES. The easiest way to think about it is like a license to discharge. If a factory or a plant releases wastewater from a specific spot, like a pipe, it has to have an NPDES permit. This is basically the government's #1 tool for controlling water pollution.
So here's the crucial link. If the NPDES permit is the license, then Part 125 is the rulebook that tells you what you have to do to get and keep that license. It sets the minimum technology standards that have to be used. And that's key. It's not just about a pollution limit. It's about mandating that industries use the right kind of tech from the get-go.
So let's start with the side of this that most people think of when they hear water pollution, managing what's actually coming out of the discharge pipe. And this is where Part 125 gets really specific.
And this is a really, really important idea to grasp. The law doesn't just say, hey, try to keep the river clean. It forces what's called a technology-based approach. It says you must use a certain level of treatment technology. This creates a standard for everyone, everywhere, and it really pushes industries to innovate and get better at controlling pollution.
And this slide lays out that technology ladder perfectly. Think of it in steps. At the bottom, you've got BPT, or Best Practicable Technology. That's the baseline. Then you step up to BCT for more common pollutants. And at the very top, you have BAT, or Best Available Technology. This is the heavy hitter, aimed at the really nasty stuff like toxic chemicals, and it requires the best tech that's also economically achievable.
Okay, we've covered what comes out. Now let's flip to the other side of the pipe and look at how these rules handle the environmental impact of pulling water in. This is a part of the equation that often gets overlooked, but its ecological footprint can be massive.
Just picture a big power plant. To keep its equipment cool, it has to pull in unbelievable amounts of water from a river or a lake. Now, this isn't a chemical pollution problem, it's a physical one. The sheer force and volume of that intake pipe basically acts like a giant underwater vacuum cleaner, and that's where the real damage starts. And that vacuum cleaner causes harm in two distinct ways. First, there's impingement. That's when bigger fish get literally pinned against the intake screens by the force of the water. Then there's entrainment, which is even more devastating. That's when tiny organisms, we're talking fish eggs, larvae, are small enough to get pulled right through the screens and into the guts of the cooling system.
So how do you fix that? Well, just like with the discharge rules, the solution is all about technology. Part 125 says facilities have to use the best technology available to cut down on both impingement and entrainment. And that can mean anything from designing better screens to totally rethinking the cooling system itself.
And here's a perfect real-world example of that in action. For a lot of new facilities, the rules set a maximum speed limit for the water at the intake screen, 0.5 foot per second. Why that specific number? Because it's slow enough that most fish can easily swim away instead of getting trapped. It's a simple, brilliant engineering fix for a big biological problem.
But here's where things get interesting. The rules aren't one size fits all. If you're building a brand new facility, you have to meet these really strict, clear-cut national standards. But for existing plants, which might be decades old, the rules are more flexible. Regulators figure out the best technology available on a case-by-case basis, taking into account what's actually feasible for that specific site.
So, we've got these super detailed rules for water going in and water coming out. But how does this all actually work? How is it managed and enforced on the ground day to day?
Well, the answer brings us right back to that NPDES permit. This single legal document is where the rubber really meets the road. It takes all those general requirements from Part 125 and turns them into a specific, tailor-made, and legally binding set of obligations for one facility.
And getting a permit isn't a one-and-done deal. It's a continuous cycle.
A facility applies with a ton of technical data. The regulators use that to set specific limits. Then, the facility has to constantly monitor itself and report back to prove it's in compliance. And, this is crucial, every 5 years or so, the whole permit gets reviewed and renewed. It's a system designed for long-term accountability.
Now, you might be thinking this sounds incredibly rigid, but the system does have some built-in common sense. Part 125 allows for exceptions. If a facility can prove its situation is fundamentally different, it can ask for a variance. There are also special rules for heat discharges, and like we said, that case-by-case analysis gives regulators room to find solutions that make sense for unique sites.
Okay, we've been pretty deep in the technical details, so let's pull back for a second and look at the big picture. Why does this whole complicated system of permits and tech standards really, truly matter?
At its heart, it's about protecting a resource we all share. These rules protect our rivers and lakes from both chemical and physical harm. They also create a level playing field so companies doing the right thing aren't undercut by competitors cutting corners. And of course, this all safeguards our drinking water and the places we swim and fish. For businesses, compliance is just smart. It's about being a good neighbor and avoiding the massive penalties that come with breaking the rules.
And this brings us to a really cool final thought. Because the whole system is tied to this idea of best available technology, it's designed to evolve. It's not static. As our science and engineering get better, the definition of best available is going to change with it. So this whole framework isn't just about cleaning up water today. It's a built-in promise to keep using our best ideas to protect it, long into the future.
If you found this helpful or want to stay updated when this regulation changes, subscribe and support the channel. And if you need the full technical details on this CFR, click the link in the description below. See you next time.